Okay, so once again, I'd like to welcome you, and I think we are prepared to start now. It's 4 minutes past 8. And prior to the start, let's do some minor housekeeping. First of all, this event is going to be recorded, so by participating in the event, you agree that the organizer is allowed to take pictures and recordings, and you authorize the distribution of the video recording via the internet or other communication channels without compensation. Furthermore, please mute your microphone during the presentations. At the end of any presentation, there's the possibility to ask questions by using the audio function. You can use the chat function to place questions. The speakers try to consider those questions during their presentations. So please consider this. As I said, I'd like to welcome you here to our CAN Technology Day with the subject CANopen FD. Briefly to my person, my name is Reiner Zitzmann, now today from the home office. I'm the General Manager of Canon Automation GmbH, so I manage the office in Nuremberg, and furthermore I represent Canon Automation in several international standardization groups. I've been a project leader of CANopen in the ICTC 69 WG10. I'm an expert in the rail vehicles group for standardizing CANopen on a consist level. And finally, I standardized CANopen also on truck-mounted applications such as garbage trucks, and represent CAN Automation in the interests of our CAN members on the European and German level of the corresponding mirror groups. So much briefly to my background, and I will guide you through this technology day from Canon Automation. So briefly to the agenda, I will give you a short introduction to Canon Automation. Maybe some of the attendees are not that well aware of Canon Automation and what Canon Automation is doing. Furthermore, I will give the first presentation a short introduction to CANopen FD. How does CANopen FD work? What are the essentials? Then we will have a first breakpoint. In this break, I will hand over to a colleague from mine, and she will introduce us to the CA marketing opportunities. Maybe this is of interest for you, and say, oh, I would like to join these possibilities offered by Canon Automation. Then in the next session, I will provide you an insight to a new communication mean provided by CANopen FD, the USDO protocol. I will show you some details and some possibilities how to use these new functions added to the CANopen environment. Then I will hand over to my colleague, Ms. Yao. She will introduce us some assignment methods of a network ID and a node ID to CANopen FD. And then we have reached the next breakpoint. And after that, my colleague, Mr. Kaplun, he will show us the modified startup procedure for CANopen FD now, using the new communication technology CANopen FD and CANFD. Then we have once again Ms. Yao. She gives us some hints to the network design, how to set up a CANopen FD network. And finally, after last breakpoint, Mr. Kaplun will inform us on CANopen FD device description and conformance testing. So this is a lineup for the day. And briefly, I will give to those that are not aware who is Canon Automation, what is Canon Automation doing, a short introduction. So Canon Automation is an international users and manufacturers group that develops and supports CANopen and other CAN-based high-layer protocols. The non-profit group has been founded in 1992 to provide CAN-based technology, product, and marketing information. The association fosters the image of the CAN technology and provides a path to future technologies. So in words, I would say we offer you a huge social network of CAN experts, CAN users, developers, and if you have any challenges in your CAN-based project, then we would appreciate that you contact CAN Automation, that you place there your questions. Maybe we can assist you directly and you can accelerate with your project, or the other way around. We can rely on our huge social network, and we know there's somebody who's focused on these kind of challenges, and we can direct you to them and say, well, please assist them to overcome their challenges in their project. So therefore, it's a very beneficial being part of this CAN Automation offered social network. Where is CAN Automation? We are located in Germany, in southern part of Germany, Bavaria, in Nuremberg, in the city center. So maybe usually in non-corona times, you are coming to to Nuremberg for Embedded Fair, for SBS Fair, and so we are located in the very same town in Nuremberg, in the city center. And if you have any technical issues to discuss, then you're invited to come to CAN Automation and place your questions, discuss your challenges, and we try to assist you. Briefly to the history of CAN Automation. CAN Automation has been founded, as I've said, in 1992 by the founding members, Berghoff, ESD, Geiser, Jin, LP Electronic, MEN Technology Partnership, and Mr. Holger Salzwanger. And CAN Automation tries to raise the awareness of CAN technology. This we do, for example, with a magazine that appears quarterly, the CAN newsletter. We go to relevant fairs. The first one had been the Interkammer in Düsseldorf. And we organize conferences, technology days, seminars, and so on to widespread the information about CAN worldwide. On the other hand, CAN Automation offers a neutral ground that companies can meet and can discuss how to use CAN in a specific project, and therefore we generate together with these companies on the neutral ground CAN Automation specifications. So the first one has been the CR 102 document, where we discussed how could a physical layer for classical CAN look like. Then the document 200, where we discussed how to use the CAN frames. And since 1994, CAN Automation has been maintaining and doing some further development for the classic CANopen. And you see later on in this lineup that CAN Automation organized an international CAN conference, the 13th one. And this international CAN conference was used by Bosch to present the next generation of CAN, the CAN FD. This had been in the year 2012. And in 2017, CAN Automation had updated the CAN-based high-layer protocol CANopen with regard to CAN FD and published the document 1301 CANopen FD. And the history of CAN has not been written yet. We are still writing on it, and at the moment there exists a group that is trying to organize the next generation of CAN. It's called CAN XL, and we think about this for the year, I think maybe 2025 or something like that. CAN Automation is a members-based organization at the moment with about 670 member companies. So you see, although there are a lot of competing networking technologies, a lot of companies think that CAN is still very relevant for them, and therefore they become member in CAN Automation to participate in the social network offered by CAN Automation and to be a part of this social network. What we are doing in our association, we have two major parts. We have a technical part, we have a marketing part. The technical part controlled or managed by the technical committee, where Mr. Uwe Koppe from Microcontrol is the technical director, and he chairs this steering committee. And the steering committee coordinates the activities of 6 working groups, major working groups. One dealing with CANopen, the interest group CANopen. We have a new one, the interest group CANopen FD. managing all the issues coming up with regard to CANopen FD, as we want to, or as we try to keep our technologies independent from the, or our profiles independent from the communication technology. We organized a new working group, the working group profiles, that shall maintain, independent of the communication interface, the way specific devices organize their data, like I/O modules, drives, and so on. Then we have a working group that focuses on the data link layer level and the physical layer level. So according to the OSI reference model, the layers 1 and 2. So this is the layer 1 and 2 group. And this is also the group that is, on the one hand, evaluating and discussing the CAN-FD physical layer. On the other hand, they're paving the path to the future. They're organizing also the CAN-XL groups. Then we have a working group that is accompanying the mapping of J9039 to CAN-FD at the SIE level. So this is this interest group J9039. And furthermore, as CAN Automation got aware that also the embedded level based on CAN is now threatened by certain security issues. We have a new working group, Safety and Security, that monitors the corresponding upcoming issues and tries to provide answer in the working group. So this is a very, let's say, slow working group, but from time to time they meet and try to provide solutions if there are upcoming issues. Today in our technology day, we want to focus on the topics discussed and managed by the interest group CANopen FD. How does CANopen FD work? Node ID assignment, testing, electronic device descriptions, boot up procedure, and so on. So this will be the focus today. And if you are interested in all these topics we are presenting, then please feel free to join these working groups. Maybe if you are non-member, as a guest, if you are a member, then it's very easy for you getting access to these groups and stimulating the work in the direction that your challenges and your interests are covered. As I said, on the other hand, we have some marketing groups. The marketing groups try to open markets for CANopen and CAN-based solutions, try to widespread the information about CAN by means of demonstrators, presenting on relevant fairs, producing image videos, taking part on conferences, generating some kind of publications. And these groups we have for CANopen FD, so the subject of today, but also for lift and municipal vehicles. So if you try or if you like to join some marketing activities organized by CAN Automation, you can also join this. What is CAN Automation doing? In brief, CAN Automation is on the one hand maintaining its specifications. Furthermore, it tries to give these specifications a certain degree of importance. We submit them to ISO and IEC for international standardization. Then we have to do some marketing for these kind of specifications to raise the awareness. We offer also some marketing channels for our members. And on the other hand, we provide some technical information. We organize technical-oriented seminars, consultancy services, and testing for CANopen. We have conformance testing also for CANopen FD. We have a testing procedure. And furthermore, it gets more and more important to offer something that is called CAN Automation Plug Test or interoperability test for a specific market. Finally, I like to point to the International CAN Conference that should have been this year, but unfortunately we had to postpone it because of the occurrence of the coronavirus. So as a result, we had to shift the International CAN Conference. We hope now that the situation around Corona is getting better and better in a way that we can have the International CAN Conference in June, 15th, 16th of June next year. So the proceedings are already available. They had been written to the original date. So if you want to see which topics should have been discussed in March and will be discussed now in June next year, then you can order these proceedings already at CAN Automation office. And finally, I'd like to point you on the publications of CAN Automation for being kept informed what's going on in the CAN application field. So we have there the newsletter magazine, the newsletter online. We have our product guides that show you which products are available on the market. We have our website that provides you with upcoming news. And you can register for the CAN Automation email services, the info mail, the members news, which provides you monthly what's going on in the CAN business. Of course, these kind of publications are also well suited to reach intended audience, experts. So you have also the option, if you develop some interesting solutions, to place there some articles to describe you as an expert in CAN-based networking and to place advertisement. Yeah, so much with regards to CAN Automation. As I said, we are a members-based organization. The major benefit, I would say, being member of CAN Automation is that you have access to all the specifications in all development stages. And furthermore, you can take part in CAN Automation events such as Plugfest, interoperability tests, marketing activities. You have better options in our marketing opportunities, which we will have later on. And of course, you help developing the market, which allows you to reach more customers. Yeah, somewhat briefly about CAN Automation, and of course, we would appreciate to welcome you as CAN Automation member in one of our working groups and our activities. So much briefly with regard to CAN Automation. If you have any questions to that, you can ask them now, or you can also use the chat function, and I will try to consider this during my presentation. But I don't see any indication of a question with regard to the presented content at the moment, so I would like to proceed therefore with our first topic, and the first topic is the CANopen FD introduction. Yeah, with regards to CANopen FD, why does CANopen FD exist? We had the well-established CANopen high-layer protocol, CAN-based high-layer protocol, and then when CAN FD came up with a lengthened data field and higher communication speed, many people said, well, how could we use these benefits now provided by CAN FD from the point of view of a higher-layer protocol such as CANopen? So why not updating CANopen in a way that we can make use of these features provided by CAN FD? And this would allow us to use this reliable, very flexible, scalable high-layer protocol also in CAN FD and to use this functionality. So this was the starting point for the work of the interest group CANopen FD, and we updated CANopen with regards to CAN FD, and you see we run it on a CAN FD physical layer, on a CAN FD data link layer, and then we have there our protocol stack, the CANopen FD protocol stack that makes use of the functionality provided by the CAN FD controller. So CANopen FD is as CANopen a higher layer protocol, a CAN-based higher layer protocol. So we could now just focus on the higher layer, but as CANopen, also CANopen FD has some expectation on the implementation of the lower layers, on the data link layer, on the physical layer, and therefore we will also have a small look on these kind of expectations. What does CANopen FD expect on these lower layers? But prior to this, let's have a small reminder, what is CAN FD? And here you see the comparison classical CAN and CAN FD. On a first sight, it looks completely identical. You have the same number of fields, you have the same naming of the fields. So this is all identical. Some fields just differ in the amount of bits. So you see we have a little bit enlarged control field. We have a larger data field. We have now the size of 64 bytes in the data field compared to former 8 bytes. Of course, we have an adapted CRC field, and all the rest remains identical. So we can make use of an enlarged data field And we see here in this green block, there's a data transmission phase. This shall indicate or remind you that we can transmit the data field with an accelerated communication speed. And therefore, we can transfer more data in the same time as in compared to a classical CAN frame. So if you want to have some details, you can go to the ICC paper from 2012, where Mr. Florian Hartwig from Bosch presented what can you achieve with CAN FD. And there he said, okay, let's start with a CAN frame on 500 kilobit, and let's turn up the speed in this data phase up to 4 Mbit, and then you see you come to an average speed of roughly 1.4 Mbit. If you are enlarging the data field, so if you increase the number of accelerated bits now, then this would lead you to a much higher average bit rate. You see this here, you reach roughly 3 Mbit in this combination. So this is, okay, we can, on the one hand, have already an impact if we just use the enlarged frames, if we just turn up the bit rate just a bit, then we can have already some profits using the enlarged data field, overcoming some challenges with regard to security, authentication, functional safety, and so on. If we just do a small bitrate switch, then we can say, okay, this shouldn't have too much impact on the physical layer, so we should be able to run today's or classical CAN topologies, network architectures, and only if we exceed the Mbit, then we have to really qualify, will this network really work? And we have to do some testing and qualification of this network. But with regard to these subjects, we will hear later on something from my colleague, Ms. Yao. I just want to give you the indication. We are working on the subject physical layer for CAN FD-based networks, such as CANopen FD. And we provide there in the document series 601 a lot of useful information. How to configure, for example, the bit timing, what about ringing suppression. If I have a lot of noise in my network, a lot of ringing, how can I achieve very quickly a good signal level so that this network can work? We are working on a reference topology for CANopen FD. We are discussing cable parameters and so on. So I think if you are planning to work with a CAN FD-based network such as CANopen FD, it's highly recommended to have a look to the CS601 document series. And CANopen FD is not introducing totally new things, but we are relying on the information that is provided by the CS600 document series for device and system design. But in addition, we have to provide, of course, bit rates. And to make CANopen FD work out of the box, we defined just bit rates, but in fact we defined the backline bit timing and bit timing settings in the CANopen FD specifications. But the end user should not see too much. For the end user, we just define pairs of bit rates supported by CANopen FD, and the specification then for the implementer will provide the specific bit timing. Don't think that we just support these 4 pairs of bit rates. They are just mandatory for any CANopen FD device to achieve a certain degree of plug-and-play functionality. But in fact, we have huge bit timing tables in our CANopen FD specification, that you have bit timings for the arbitration phase, bit timings for the data phase, and the bit timing has been chosen in a way that you should be able to combine each of these bit timings for arbitration phase and data phase, that you achieve interoperability with other devices. We learned in CAN FD that if all the devices derive the bit timing from the very same oscillator frequency by the very same baud rate prescaler settings and bit timing adjustments, that then CANFD works in the best way. Therefore, CANopen FD at the moment provides just the bit timing table based on 80 megahertz. Unfortunately, we see now that there exist microcontrollers with onboard CAN controllers that are based on 40 megahertz. And some of them are well suited, for example, for small sensors and something like that. So this forces us that we said, for those kind of microcontrollers, we have also to provide a bit timing. And therefore, at the moment, we are introducing a bit timing similar to this, what you see here on the table, for 40 megahertz. It's currently ongoing. If you're interested in these things, then please join the group. More with regard to the lower layers, we will hear later on. Therefore, let's just focus, what is a CANopen FD device? And therefore, we have a nice description now in our CANopen FD specification. And there we see a CANopen FD device is always based in a field device. So a field device is something that you can touch, which has a cover. So you can take in your hand, for example, and there should be inside a microcontroller with a kind of CAN controller. This is your CAN-FD device, a CAN-FD capable CAN controller. And this CAN-FD device has some bitrate settings for the nominal bitrate, which is used in the arbitration phase, for the bitrate that is used in the data phase. And these bitrates are inherited by the CANopen FD device that resides on the CAN-FD device. And such a CANopen FD device has now not only a node ID, but a network ID. The network ID we are using later on, especially for routing functionality, that we can use some communication means by exceeding network barriers in an entire CANopen FD system. So a CANopen FD device has now network ID, node ID. In principle, the network ID works similar to a node ID. It has to be available when a CANopen FD device starts up and is ready to work. Such a CANopen FD device hosts an NMT slave functionality. In addition to that, it may host an NMT master functionality. It has an error handler for managing upcoming errors. And on a CANopen FD device, there may be one or several SIA device and application profiles supported. So these are so-called logical devices, and the amount of device and application profiles that are implemented, in fact, you can see in an updated Object 1000. The Object 1000 is now an array, and this array lists which kind of SIA profiles are implemented. And in addition to that, and in parallel to all the standardized functionality, CANopen FD as CANopen provides you the possibility to provide additional manufacturer-specific functions. So this is a basic setup of a CANopen FD device. And this CANopen FD device, of course, has a communication state machine, so similar to that we know from classical CANopen, the network management, find a state automaton. And if you switch on a CANopen FD device, it goes into the application reset state, it initializes, sets the network ID and the node ID value. So it is now also clarified in which communication state these values are set active, are visible to the outside world. And then if the entire CANopen FD device is initialized, then we are entering the communication state. So these well-known substates, pre-operational, operational, and stop, they exist also in CANopen FD, and they are summarized in one super state, the so-called communicating state. In parallel to this communicating state, we have also now here considered a master FSA, a NMT master state machine. So we defined also in the basic CANopen specification when gets a CANopen FD master functionality active, if there is a master functionality supported. So we know a lot of CANopen masters out there in the market, but a CANopen master, in fact, has never been defined in the CANopen environment. Here in CANopen FD, we have now defined what is a CANopen FD master and which kind of functionality has to be available. Therefore, we have seen on the previous slide the CANopen FD device architecture and here the state machine. Let's have some words with regard to network ID and node ID. We have the node ID. It works identical to CANopen. We have a unique node ID value from 1 to 7F, and we have, for example, for the purpose of layer setting services, the FF to indicate that we have an invalid CANopen node ID, in this case a CANopen FD node ID, and we wait somewhere in its initialization that somebody configures us a valid node ID value so that we can start up. A similar thing we have for the network ID to map, for example, several virtual networks on the same cable, or to use, for example, some kind of gateway functionality or routing functionality to communicate via network barriers. We have also for every CANopen FD device a network ID. And every CANopen FD device has therefore to know what is the node number in the current network and what is the network number of the current network. So to ease configurations, we have also a specific value, that's the 0. So if a CANopen FD device supports the 0 as network ID, it's able to start up. And this CANopen FD device is just not aware of its network ID, but is capable to operate remote services. So this with regard to the network ID. Let's have a brief look on the different services. So when we updated the protocol stack of CANopen with regard to CANopen FD, we analyzed the services and we said, okay, we want only to make changes where it is really reasonable. We don't want to change everything, but only there where it's very reasonable, and we want to keep a lot of the knowledge and the functionality that you're aware in classic CANopen. So therefore, we analyzed which kind of services are really limited by a classical CAN frame. And the result of this evaluation had been everything what you see here in this blue box is not really limited by classical CAN frames. The SYNC protocol, 0 byte or 1 byte of payload. The timestamp, 6 byte of payload. The NMT protocol, 2 bytes, boot up, heartbeat, 1 byte of payload. So here, the benefit of using CAN-FD is very limited. On the other hand, we have there some transport-oriented protocols such as PDOs, SDOs. They are limited in their efficiency by the payload of a classical CAN frame, and they would benefit in maximum from an enlarged data field and from a higher communication speed in CAN-FD. And similar it is with the emergency protocol. The emergency protocol that communicates application-related errors occurred in a certain device in the network. They are also limited by the classical CAN frame payload. We are going to update these services. So why is this node guarding protocol red? On the one hand, we want to get rid of this node guarding protocol already in CANopen, in classic CANopen. Now in CAN-FD, we have to consider that remote frames in CAN-FD frame format are no longer supported, and therefore we said, okay, just remove it, and we don't support it anymore in CANopen FD. So let's have a brief look over the services. How did we update these services? Briefly, PDO. A PDO is mapped to one single CAN message, now no longer to 8 byte, but to a CAN message of 64 byte payload. So we have here our application objects mapped to this payload. We have no possibility to trigger these messages via remote frames. Let's remind you briefly, where do we have to update something? Therefore, let's remind us, how are PDOs defined? You have 2 parameter sets for defining one PDO, the communication parameters and the mapping parameters. Let's have a short example that you understand this. You have your communication parameters. This indicates which CAN frame is considered as a certain PDO, and then you have a mapping table that identifies the content. And this means here we just have to make sure that we can now map 64 entries into our PDO. We had in the past a threshold value of 8 bytes, as we have in a classical CAN frame the payload of 8 bytes. Now we're a payload of 64 bytes, so this is our new threshold value. And this is everything we have to change, because in the description then of the mapping parameters, we have already the space to map 64 objects, 64 byte-wise to a PDO. So in the stack, we don't have to change anything except of the threshold value updated to 64. There's one other thing to consider in PDOs. CAN frames cannot be adapted with regard to the payload to the real needed payload, but you can extend CAN FD frames only in certain steps. You see this here. We support smoothly from 0 to 8 bytes the payload in CAN FD as in classical CAN, but then we can extend CAN FD frames only in certain steps, 12 bytes, 16 bytes, 20 bytes, and so on, up to 64. So this means if I want to send 50 bytes of data, I will get in any case 64 bytes of data. So therefore, I should consider mapping bytes, padding bytes in my mapping to get a defined structured PDO, not to run into any trouble. We will hear later on a lot more with regards to this thing here, the universal SDO. We updated also the service data object, but not directly, because it was very tricky and looked very handy-made. Therefore, we removed the classical SDO and substituted the classical SDO by something new, the so-called universal service data object, or briefly the USDO. The USDO has a full function coverage of the classic SDO, but in addition to that, we have now the possibility of multicast and broadcast communication. We have the possibility of parallel access to the very same server. We have an inherent routing capability. This is why we also need a network ID. And we are working on some nice gimmicks like multiple subindex access, addressing via logical names, which helps us, for example, in IoT applications. So all these things are provided now by an USDO, and it's easy extendable. We had a special eye on keeping the USDO very simple with regard to the implementation. We also considered byte alignment. So you see here briefly how this USDO works. We don't have the bit flipping here always, all the time, but we have nice byte-oriented fields, which are also extendable if we want to add some new functionality. So much in brief with regards to the USDO. I will have an entire presentation about USDOs after the next breakpoint. Let's have briefly a look on other functionality. So, for example, the error handling, the error FSA is identical to that in classic CANopen. We have two states, error-free, error occurred, and we have an insight to this error state machine via the object 1001. And any transition here in this error state machine may trigger the transmission of the emergency protocol, the MC write protocol. And if you are a little bit well trained in classic CANopen, then you will figure out that we have here our classical error code, we have the error register, and we have the manufacturer specific error information. But this is now extended by a timestamp, by a status that identifies this kind of error. Is it, for example, recoverable or non-recoverable? And in classic CANopen, we have a kind of weakness that we use in several CANopen device or application profiles, similar error codes. And now to identify which document is the origin of this error code for a correct interpretation of this error code, we have now the possibility to indicate, okay, we have the error code, from which specification is this error code, that you know what is the correct meaning. And As devices get more powerful, more complex, there may be more logical devices. So, for example, for a multi-axle system, I may have a device like a XY table supporting 2 axles. They are using identical device profiles, identical error codes, so it would be necessary, was it the X-axle or the Y-axle generating this error? So we have also the possibility to indicate the logical device number. For error handling, we have a lot of new further functionality in CANopen FD. We have an active error history. All these extended error information can be stored in an error history domain that can be very, very powerful, and therefore it's important to have a management object, a management object for this error history domain, so I can see how many error entries do I have there in this error history domain. I want to delete certain errors, for example, the error vanish events. I don't need anymore. I can delete them to make some additional memory available, or a certain error class I want to remove, like recoverable error events, and I can choose the type of recording. All this is now available in CANopen FD. Now, as this is can get a very huge error history domain, maybe on a first sight, I just want to see what are the current active errors. Therefore, I have another new object, the object 1032, which indicates which are the current active errors. Additionally to that, we have some new data objects. We have a slight change in the device type object 1000. It's now an array indicating which device profiles are implemented, a version information, which profiles in which version are implemented, some routing information, and the object 1F80 is now provided in the basic CANopen FD specification to indicate the NFT startup behavior. We tested CANopen FD already in several plugfests. So the main issue had been on the physical layer to raise awareness. Okay, we have to be more specific now in the bit timings, in the bit timing settings, in the implementation of the bus line. All the rest with regards to the protocol worked more or less out of the box. So you see here some milestones. We had already some demonstrators on the relevant fairs. We published the document 1301, and first devices are available and exhibited. So we have CANopen FD stacks from EMSA, EMOTAS, ESD, microcontrol. We have I/O modules already exhibited on our booth. We have first gateways from CANopen to CANopen FD. So therefore, we can say it's time for CANopen FD. Details on these things and latest news are always available in our CAN newsletter or in the conference proceedings to the International CAN Conference 2020. Nevertheless, there's something to do. So we are at the moment evaluating, let's say, variable data fields, for example, for security purposes, that we can add to CANopen FD some security functionality. We are working on the startup procedure and the network management for CANopen FD. How can we use the new CANopen FD services, updated services, for a smart boot up and network management process? What about network ID and node ID assignment? What about testing and device description? As I've already introduced, we are working at the moment on a 40 megahertz bit timing table. We are working on reference topologies that should work out of the box. And we are updating our CANopen profile. So if you are interested in CANopen FD and using CANopen FD, and you want to make sure that your interests from a user perspective or developer's perspective are covered, then we would appreciate your contribution. Submit comments, join the group. Especially in the time of Corona, it's rather simple to do so because most of our activities are at the moment running on a web page. So, summing up, the basic CANopen functionality remains unchanged. We have now the possibility to use 64-byte PDOs that might be very useful, for example, for adding some security features like authentication of the right sources and so on. We substituted the SDO by the USDO that allows cross-communication, establishing dynamical during system runtime. So if systems are changing, you have the possibility, nevertheless, without the existence of a system integrator, to establish dynamical cross-communication between all the network participants. This will be discussed later on. And furthermore, you have enhanced functionality for maintenance. Yeah, so much with regard to an introduction to CANopen FD. We will continue at 9 o'clock German time with the next subject. In the meantime, my colleagues will use this first break to present you some marketing information, some news from CAN Automation Marketing.
Hello everyone, my name is Meng Xie-Buchert from the CIA Marketing Department. I'm very glad to have the opportunity today to run a short presentation about the CIA marketing services, which we offer to our members and non-members. So the CAN Automation provides a range of marketing services for promoting the CAN technology. The main important services are publications, trade shows, and events. In our publications, as a platform for your advertisement, you can choose between the CAN Newsletter Magazine, CAN Newsletter Online, the CIA product guides, and the event stage. And enter the CIA product guides, where you can choose between 3 categories, named CANopen or CANopen FD, CAN, and also CAN FD and J9039 to place information about your products. The CIA participate each year different trade shows with the aim to present and promote CAN image. There are several forms for participation for CIA members, as a co-exhibitor at CIA joint stands, or promoting your products and solutions together with other member companies. Or you can also presenting your CANopen related products on CANopen product panel at the CIA booth. CIA also organized a range of events as ICC, the International CAN Conference, the CAN Technology Days, and the seminars in online and offline forms. Here you can also find our contact from our marketing teams, and please contact us if you have any question regarding the CIA marketing opportunities. To the details to the CAN publications. The CAN Newsletter Magazine provided the technical article and application reports for engineers designing CAN products and CAN systems. This technical magazine is being published quarterly. The subscriber or the readers of the CAN newsletter increased from year to year. In 2019, we have more than 381,000 downloads. You can download the whole magazine or single articles free of charge. Prices for advertisement in this magazine are very reasonable. And beside the technical magazine, we also have the CAN Newsletter online version, which provides current product news, CAN-related development and marketing activities. The sponsored links to related products of the CIA product guides and to company profiles of the CIA member companies completed this source of information. You have an opportunity to book banner advertisements like skyscraper, head banner, or side banner for promoting your products. Here is our CIA product guides. The product guides list the CAN and CANFD, CANopen, also CANopen FD, and J9039 devices, together with their features and worldwide sales contact. The entry is highly integrated into the CAN Newsletter Online and other CIA publications with our cross-media concept. And as you know, because of the spread of coronavirus, we launched our new services, the CIA event stage. This platform helps you to find out CAN-related events where you can meet international experts and find partners. As well, you can use the platform for advertise your own events. So here you can find some figures about CIA's media kit. All CIA marketing products are highly cross-referenced with each other. It means an advertisement will be seen several times in the CIA publications. As you see, the CAN Newsletter magazine had more than 381,000 downloads in 2019, and the CAN Newsletter online has been visited more than 129,000 times last year. So please don't miss the deadline for your advertisement. The next deadline for CAN Newsletter September issue is the 3rd of August. As I mentioned before, CIA also organized technical events like International CAN Conference, CAN Technology Days, seminars in online as well as offline forms. The most important event is our ICC, which will be held on 15th and 16th of June next year in Baden-Baden, Germany. You can contact the CIA office for registration or purchase of the proceedings. The CIA goes every year to different international trade shows with the aim to present and promote CAN image. You can find here our exhibition calendar. CIA member could participate as co-exhibitors. At the picture, you can see this is our jump stand at the Bauma Munich 2016. And for example, we have this year also at the ConExpo with 3 exhibitors, and at the Bauma China in November with 4 co-exhibitors. Also, you can also presenting your CANopen related products at the products panel. You have also the opportunities to present your new product and solutions together with other member companies to build a demonstrator. So if you have any questions about the CIA marketing issues, please find the contact here in the presentation. Our marketing team will be very glad to help you to find a suitable offer for you. You can also follow us in the social media to get the latest news in the CAN community. So thank you for your information. I will give over the presentation back to Ms. Zitzmann.
So thank you, Meng. So if anybody has some questions, please use the contact as seen here, or you have also now the possibility to ask questions to our marketing team. Okay, I think we can continue, and I hope you see my slides once again. So the next subject is a detailed view on the USDO protocol and to discuss some kind of applications, some use cases where the use of the USDO protocol can be very beneficial. So if we start with the look to the USDO, let's have a look on the classical SDO. So I'd like to remind you that the classical SDO is a communication between an SDO client that initiates the access to the object dictionary of the so-called server. And this communication is determined by a pair of CAN identifiers. You have 2 CAN identifiers, the one for using for carrying the request from the client to the server, and another one for carrying the answer from the server to the client. So for this, you need typically a system integrator that configures who shall act as a client for the server, as typically every server provides us with a pair of CAN identifiers for access to its own object dictionary, and it's not up to the system integrator to decide which device shall become client to which server. So in an average system, you have here maybe a big host controller, maybe in our case device A, and this claims all the servers from all the end devices. So this means it's very hard for another device to get access to another end device because the first server is already claimed. To keep the uniqueness of CAN identifiers in the system, you need another server, another pair of CAN identifiers, and then you can establish this access. There exists already a lot of CANopen devices that support a second server, but we have here the problem that in contrast to the first SDO server channel, the CAN identifiers for a second channel are not predefined by specification. Once again, I need a system designer who decides which CAN identifiers are suitable, are appropriate for this kind of communication. And also something like that, if I would need a channel back from the server to the client, in this case my server becomes client to the device A, then I would need another channel and another server functionality. And also here, not every CANopen host controller has an object dictionary, provides a server channel that I can have this access with another pair of CAN identifiers. So this would be a clean design in the classical CANopen world, but unfortunately many of the CANopen end devices just come with a single SDO server functionality, and it limits my communication functions in CANopen dramatically. So why is this the case? Why is it so difficult? Why it not possible that, for example, device B uses the same CAN identifiers as device A for accessing this server here? This is because of the allocation scheme of this CAN identifier. The CAN identifier for this SDO communication is determined by the server. We have here this formula, the communication expects for the direction client to server, a CAN identifier that follows the following formula, 600 plus node ID of the server. Here I expect my request and I provide the answer with 580 plus my node ID. So this means that I can allocate this channel here, but I have no possibility that the other device accesses this device because there are no CAN identifiers left. So summing up the features and limits of the SDO, we see it here. We have with the SDO a mean that offers us full read and write access to all data elements of a CANopen device and of all CANopen devices in the network. In theory, we can have 128 server and client channels per device and by specification. So this means we can describe also in classic CANopen a fully meshed CANopen network where every device has to every other device an SDO communication channel, can access the object dictionary, can read and write all the entries. But the limitations are the implementations. Most of the protocol stacks designed for sensors and actuators and whatever, they just support a single server channel. So if I use such stacks, I have no possibility to describe fully meshed systems. Also, classic CANopen has the possibility to describe dynamical SDO cross-communication. I can set up CANopen systems where a so-called SDO manager configures dynamically during system runtime SDO communication to other network partners. Once again, unfortunately, I have only a very limited amount of systems where this SDO manager functionality is available. And even if an SDO manager functionality is available, many of the end devices do not offer configurable SDO channels. So therefore, by specification, this functionality is provided very well, but unfortunately by implementation, it is limited dramatically. Sometimes we are asked, well, we would like to access with the very same SDO several devices, because I have, for example, during end-of-line production, several devices of the very same structure. So it would be very beneficial if I could configure these devices in the very same way, so by a single access. Or there exist applications like knitting machines, seeding machines, where you have hundreds of drives that are doing exactly the same way, the same thing. So you could or should configure them in the very same way, and a broadcast transfer would be very, very beneficial. Does not exist in classic CANopen, and there exist only manufacturer-specific SDO extensions. And furthermore, routing, if I want to overcome network barriers and to communicate in an entire CANopen network architecture, there exists in CANopen an extension, the 302-7. This is already widespreadly used, but not all the devices, especially not the end devices, are capable to trigger these routing functionality. So we can sum up, typically SDO communication is designed in a static way. A system designer is there at initial system startup, and implementations limit the functionalities of CANopen. On the other hand, we have to say we want to overcome these kind of limitations, and therefore we started our approach with the USDO. So we have the USDO, and the USDO provides us with several attributes. On the one hand, a full function coverage of the classical SDO. So this full function coverage means that I have full access to all the data elements in CANopen Object Dictionary. I have expedited, segmented, or bulk transfer. I have the possibility to access any device in the network. And furthermore, I have now some extended functionality like multicast and broadcast access. I have accelerated block transfer, the so-called bulk transfer. I have an inherent routing capability. I have the possibility of inherent routing by means of physical addressing, and maybe in future also by means of logical addressing. I have at the moment the possibility to access single data elements, but in future I may have also the option to have multiple subindex accesses. This would be very beneficial, for example, to configure PDOs by one access. And I have an updated SDO abort codes or USDO abort codes that give me detailed error information that I can adapt my behavior accordingly. So how can we achieve these functions? So therefore, let's have a look on the addressing schema in the Universal Service Data Objects. The USDO addressing differs now from the classical SDO, and the major difference is that the way the CAN identifiers that are used are assembled are in a different way. They are no longer determined by the USDO server, but by the sender of a CAN frame. So the client, when he requests a USDO server, he determines the CAN identifier by the formula 600 plus node ID of the client. This is now the big difference. And the server answers with 580 plus node ID of the server. Always the sender determines the CAN identifier. So that is a question, where's the destination coded? And the destination is now coded in the first part of the data field. And this I can modify rather easily without hurting some uniqueness rules of the CAN identifier. And this means I have here the possibility to establish very easily dynamic cross-communication. So this means I have full function coverage of the SDO. I can say I want to communicate or to access device number 5. This would be device number 5. I have a unicast access. I can, I can define groups. I can address groups here. The group management will be introduced in the next version. But for the moment, we can say, okay, I have here a group, and I can address a multicast group, or finally, a broadcast group I send to all devices in the network. How can we do this? The first byte of my data field in USDO is the USDO destination addressing, and here I have the possibility to assign the node ID, which device shall receive and process this USDO request. This would be the unicast option. I can address groups, or I can address all nodes in the network. So this is, for example, beneficial for a system startup. I can read all the objects 1000, and I can see where I get a response. Okay, there at this device, at this node ID, there resides the device, and I see directly which device profile is implemented. I have various transfer types. This is now coded in the command specifier, not bitwise, but as a byte-wise number. And we see here the command specifiers that I use for indicating upload, download, in an expedited, segmented way, bulk transfer, remote access, and so on. The next one is the session ID. The session ID is a kind of transaction number. It identifies exactly one USDO transfer between one USDO server and one USDO client. It is equal in all transactions of exactly one USDO transfer. It differs for all running USDO transfers between a client and a server. And it enables parallel USDO access from a USDO client to the very same USDO server. So this means you could run, for example, a firmware update, and you can open up another USDO channel to evaluate what is the process of this firmware update. Is everything working correctly? When can we assess that we have finalized this firmware update? So it can be a very interesting functionality realized by this transaction number. Furthermore, I know a lot of implementations from CANopen host controllers. They send out one request after the other without waiting for the answer, without waiting for confirmation. This transaction number helps you to reassemble all the answers to these questions and to get the entire responses in the right order. Another exception here is, or an extension to the classical SDO, is that we describe the data that is transferred. So the sender of the data is describing this data by size and data type. In the best case, maybe you're not really aware of all the things, then you can say, okay, it's unknown. But if you have the information, it would be beneficial, for example, then at the end for tools, that they can say exactly, okay, which data or which kind of data had been transferred then. And on the other hand, you can use this for testing or confirmation of your configuration. We support the segmented access. It had been a little bit simplified. You have now here a counter byte, and you see you're always using full CAN FD frames except of the last frames. The last frame will be shortened and adapted according to the real payload. Unfortunately, we have only the possibility to extend a CAN FD frame step by step. So therefore, we need size of last segment to indicate what is real needed data and what is maybe a padding byte. So there we have a download segmented service where every segment is confirmed. In contrast to, or in addition to this, we have also a bulk transfer, a very simple transfer optimized for transferring large data blocks like firmware or something like that. And what we say here is we have just a small prologue where we inform what is the size of the data we intend to transfer, where we inform in this communication from the server perspective, what are my my timing constraints. So what is my processing time for processing a received segment, that the client has an idea, okay, what is the interval or the frequency which I can use to provide new data to my server, that this transfer is most likely to work well. So the client can now consider this time and can provide segment by segment in the intended time or suitable time. So we have this transfer, a very simple transfer, and at the end it is finalized in a similar way as it had been for the segmented transfer, and it's then at the end confirmed, okay, I received all your segments correctly. So if everything went correctly, then you can save a lot of time compared to the segmented transfer. We had also a question in the chat, so there's just the last confirmation here. I don't have intermediate confirmations in between. Yeah, this is the functionality at the moment covered in the USDO. Additionally, we are working on some extensions like a multiple sub-index access. Would be nice if you think in the forward direction, okay, I can read with, for example, one access, several sub-indices or maybe also indices. It gets a little bit more tricky if you go into the details and think about also in the right direction. If there's something wrong, what will really happen? As I said, this is currently in discussion. If you're interested in this service, please join these discussions and we can accelerate the introduction of such a service. We have also in our USDO update in the CANopen FD detailed error codes now. And on the one hand, they are new error codes. They are much more specific. And we have also descriptions added that implementers know for which use case a certain error code is intended. So, for example, that the USDO timeout error, there had been no response during the timeout time. So you have in the USDO a certain timeout time in which you expect a corresponding response. If it was not there, then you will send out this abort message with this abort code. You see here the abort message, and then you see the corresponding code. Or you have an incorrect data size, or you run out of memory. So this is just a very small excerpt of error code. There are much more available in this specification. What is also of interest in USDO is that you have long distance routing already supported. Every CANopen FD device has to support this. Therefore, we need network ID in any CANopen device. So we have also the option that a CANopen device can say the network ID is unknown, but even in this case, CANopen FD device has to be capable to handle the long distance transfer, that from another network I can send this message, I want to read something, and the gateway remaps this then address, puts the local address and can place this request to the right end device, and the end device, even if it's not aware of its own network ID, it just swaps source network ID, source node ID, and destination network ID and node ID, and can provide then the corresponding content to the requesting device. So you see what is everything covered here in our CANopen FD. This, especially this routing and the USDO, this is well suited also for thinking about migration paths, that you want to combine a network that is CANopen based with a CANopen FD based world. And to think about this, we have to think there had to be a routing device in between. So a device, a microcontroller with two CAN controllers, one is running in the classical CAN mode, another one running in the CAN FD mode. And then you have this router functionality in between. And for PDOs, we have there already functionality covered in 302-7, but for SDO accesses, we have also to consider now our USDO. And we see here, for example, the remote SDO in the classical CANopen world allows us via such a gateway functionality to access a CANopen FD environment. And then on the CANopen FD side, we can use the USDO read and write request because we have a full function coverage of the SDO functions in the USDO world. And the other way around, if we use the same function coverage on the USDO, on the CANopen FD world, we can handle in the CANopen world this functionality via SDOs. So something like that already described, more or less only small extensions are missing in the document 302-7. What is not yet fully described is, as I've already pointed out, the USDO has exceeds with its function coverage the functionality of the classical SDO. So for example, if I have a broadcast USDO request, then on the CANopen side, this has to be handled as several SDO requests till I get my response. Something like that should have been added in 302-7. So if you need something like that, please contact Canon Automation, join the group, and we can finalize such kind of document very easily. So we entered already the world of the applications. Where can I use the USDO in a beneficial way? So we see this here, USDOs save time and effort, for example, for an accelerated firmware download, for accelerated upload of diagnostic memory, access to several devices in parallel, several transactions in the same device are possible. So this means we save time and effort during production and maintenance. So it would be very useful in end-of-line production. So we have CANopen FD, USDO broadcast access, or as I said, for firmware update, this could be also very useful. I see we have several questions in the chat. I will just have a look on them. You mentioned multiple USDO servers in CANopen. Does CANopen FD also allow multiple USDO servers, although there could be parallel access to a single USDO server? Yeah, it's got a little bit different in the CANopen FD side compared to classical CANopen, but if I understood your question correctly, yes, I can have from several devices, CANopen devices, parallel access to the very same CANopen FD device that acts then as a server. This I explained as it's rather simple to modify now this first data field. I don't have to consider anymore the CAN identifier. The CAN identifier uniqueness is already solved by specification, and several devices dynamically, just when it's needed, can access or can place a request to a specific CANopen device. So this allows dynamical cross-communication all over the network. Then we have another question. Are SDO frames no longer allowed in CAN FD network? Well, in CAN FD network they are allowed, so you can place a classical CANopen stack on CAN FD, but at the if you use CANopen FD in this way as it is designed now, CANopen FD uses with this USDO the CAN identifier from the SDO, so then you will get some trouble. So in a pure CANopen FD environment, SDO is substituted by the USDO. So I hope I could answer these two questions, and I will proceed with the slides. Some use cases of the USDO, for example, here, if you have CANopen-based implement, a seeding machinery, which had been presented in the last International CAN conference in Nuremberg, you may have 100 drives doing exactly the same thing in such a seeding implement. And if you want to configure them to do exactly the same, you want to write the identical configuration to these devices. In the past, this had been 100 USDO requests, 100 SDO requests. Now it's a single USDO broadcast command. So you see, it's much more efficient. Then following up the question with the dynamic cross-communication. We may have, for example, in pedelecs, the situation that the pedelec is modified by the end user. An end user may add a power supply, a charger, you would say, dynamically to the system, and it should work. He would exchange batteries, he would add batteries, he would add a service tool. So these are all dynamic components that may be there or not there, may be added during system runtime or not. And as a consequence, you would like to have dynamic cross-communication. If you add additional batteries, suddenly you want your energy management system controller to get aware of this battery, to read the functionality, and to handle this battery. The same for the power supply, maybe. You want to provide the information on the display now about the new battery, and all these things have to be handled dynamically without system integrator, because I cannot assume that the rider of a bike has necessarily CANopen knowledge and is a CANopen expert. So now, once again, reminders on the USDO. The USDO enables dynamic access to data elements during system runtime, so I can establish these communication channels very smoothly during system operation. And thanks to the function coverage of the USDO, I can access all the devices. And I don't have to fear any collisions by the CAN identifier. We have also some other applications that are already fully meshed in CANopen, classic CANopen environment, such as car add-on modules. Here we have described via SDO channels a fully meshed system, and we limited it to 16 devices so that we have enough CAN identifiers for establishing this cross communication. With USDO, this is very, very simple, because the CAN identifiers are already available. They are used in a limited way. So the destination addressing is done in the data field, and it's very, very simple now. For IoT gateways, it would be also very beneficial having this functionality. I just accelerate a bit. So if I have such an IoT gateway, if I have, for example, an implementation like that I have a well-established CANopen network, and I have now such an IoT gateway, the requirements may change during system runtime, that maybe the longer the system is available, I want to see some other data elements, some other signals, and there is no problem with CANopen FD, as any communication is data element is available during system runtime, and I have the function to access any data element in the network when it is needed. Yeah, so much to the USDO. I hope it was interesting for you and I could give you some insight on that. Just have a look what is currently done here. We are thinking about the multi-data element access, so that I could have one USDO access to configure fully PDO. This would be very beneficial. We are thinking about the logical addressing for IoT applications. And finally, we are planning further stress tests, plug tests to test various CANopen FD implementations with special regard to the USDO. Once again, your contribution would be appreciated. Please join the group and bring in your interest. Summing up, the USDO provides full function coverage of the CANopen SDO. The USDO provides dynamic cross communication as well as handling of parallel transactions. Inherent routing capability is well suited for IoT applications, and dynamic systems modified by the end user during system runtime may benefit enormously from the functions provided by the USDO. Then I like to hand over to the next contribution by my colleague, Ms. Yao.
So, hello everyone. My name is Yao Yao, and since 2016, I have been working in CAN automation as a technical manager. And so I started in University Erlangen-Nuremberg. And in CIA, I am responsible for several working groups, as for CAN FD and some working groups in CANopen FD. So as my experience show, today I will introduce something about the network ID and node ID assignment, and according to the CR document layer setting services, CR 1305. So at first, there are some relevant basic knowledges. In CANopen networks, there are 3 arts of addresses. the 16-bit index and 8-bit subindex. They are the addressing for the objects in the device object dictionary. The addresses contain specific parameters. For example, CR301 defines some addresses for COP IDs for different services. The COP IDs contain the CAN identifier, namely CAN ID. And CAN IDs identify network-wide CAN data frames and CAN remote frames. For correctly communicating, the CAN IDs for different nodes and for different services shall not be the same. And for CANopen, some predefined CAN IDs contain the node IDs at a lower 7-bit. So here now we can see a CANopen network. Each CANopen device shall be assigned with a unique node ID in the range of 1 to 127. Without such an assignment, a CANopen network can typically not start to operate because devices cannot be correctly addressed. So now the question is, how can we assign a node ID in a CANopen network, and which methods are there? So node IDs are typically set by, for example, manual configuration, deep switches, like a serial interface RS232, or human machine interfaces, or bus connector pins. But if some CANopen devices don't have a hardware interface, or if the applications require a high level of plug and play support. So in the CR305 document, it specifies the layer setting services. This could be used for such situations. So layer setting services offer the possibility to assign the node ID and the bitrate dynamically over the network. So please note that the assignment of the node ID via CANopen object dictionary, for example, via USDO, is not recommended. So today we have the topic CANopen FD. In comparison with CANopen devices, any CANopen FD device shall own one network ID and one node ID. So in addition to identifying uniquely a CANopen FD device within a CANopen FD network by the node ID, the network ID allocates a CANopen FD device clearly in a CANopen FD network. So the CANopen FD device with till the network ID is in the range of 0 to 7F hexadecimal, and the node ID values in the range of 1 to 7F hexadecimal. Then the node becomes visible at the communication interface, for example, sending a boot up message. So please note the different value ranges of the network ID and the node ID. So as Mr. Zitzmann introduced in the last part, CANopen FD distinguishes between USDO local services and USDO remote services. So by using the different values of the network ID. So far, I introduced the using of the identifiers. So then we take a look at how does the dynamic assignment of the network ID and node ID work. So by using the layer setting services. Before we go to CANopen FD, let us see at first how work the layer setting services for CANopen networks. So the layer setting service distinguishes between an RSS master and the RSS slaves. So the general sequence to assign the node ID, as shown here on the slide, the sequences is the same. The first step, RSS master identifies when one RSS slave, and then this master, the master selects this SS slave, and at the end, the master configures the node ID of this slave. So to configure the node ID, the protocol configure the protocol configured node ID protocol is used. And for identifying and selecting one slave, there are different protocols specified in the CR 305 document. So there are different mechanisms specified. But for these two blocks, the mechanism could be improved and updated. When it comes to node identifying, a basic requirement for participating devices is the availability of the 1018 identity object, which is defined in the CR 301 specification. So this identity object contains 4 sub-indexes of 32 bit each. They are vendor ID, product code, revision number, and serial number. Together, this make a unique 128-bit value that is called RSS address. So CANopen FD devices can be identified by this RS address. The sub-index 1 is the CANopen vendor ID. So CANopen vendor ID is mandatory and is a worldwide unique number assigned by CIA. So now we take a look on different cases in detail. So firstly, if RS address is known. So if there are several RSS slaves operated in the same CANopen network, the RS master has known the RS addresses of the slaves. The RS master can address one RS slave by means of the switch state selective protocol. The vendor ID, product code, revision number, and serial number are sent in 4 data frames in sequence. So then the LS address can be identified, and then the LS master will switch this LS slave into configuration state, so that the LS master is able to modify the local layer setting service, the local layer settings as node ID. So the next case could be if LS address is unknown. There are 2 mechanisms defined in CR 305. Solution 1 uses the identify remote slave service. The LS master proposes a vendor ID and a product code and the range for revision number and serial number. Then the LS master narrows the proposed LSS address range After several scan cycles, the LS master can have a single LS address, a single SS address. This solution uses long and limited scan cycles. And the back-to-back messages are also a drawback for the CANopen devices with limited performance. So it is not recommended to use this solution. So I will not introduce it in detail. So the solution 2, fast scan. This service uses only one message. Here you can see the protocol. The data field ID number contains one of the 4 parts of the LS address. The vendor ID or the other 3 parts of the LS address will be bitwise scanned. If there is at least one response from LS slaves received, the bit is set to 0. Otherwise, the bit is set to 1. Included acknowledgement for every part of the 4 part of the LS address. So 33 data frames are required. That means for the complete unknown LS address, we need 33 times 4, so 132 pair requests and responses. So this solution is already more effective than solution 1, but still more than 100 messages will be sent. So since CIA has published the CIA 1301 CANopen FD application layer and communication profile in 2017, so the CIA Special Interest Group LSSFD discusses how CANopen layer setting services should be adapted to CANopen FD. So the feature of CANopen FD to be used is the extended payload of 64 byte. The new service for CANopen FD is the LSS switch state selective FD. So this service is updated from the switch state selective and fast scan from CANopen. So this service will be also defined in the CR 1305 layer setting services for CANopen FD. So now we can see the protocol here. So instead of sending 4 messages sequentially, benefited from the CANopen FD 64 byte data payload, we could extend the data field and send the 16 byte LS address using one message. So the parameter portion is the 128-bit LSS address, which is already determined. So one other important parameter is this NIB number. So we can see here the figure above. Here is the definition for the NIB. So for this service, the LS address shall be divided into an array of 4-bit values. So there are in total 32 neighbors, and they are numbered from 0 to 31. So the parameter neighbor number is the numbers 0, 1, 2, and so on. And this number in the protocol indicates the neighbor to be checked and is sent in the request by the LS master. So a special case neighbor number is the number 32, So you see we don't have the neighbor 22, and this when and if LS master send a request with the neighbor number 32, it means this will be is used to a college and to confirmation if the full 128 bit LS address are already or checked. So what means this protocol? The LS master asks, here are the first n neighbors of the LS address. Does any device have a match? So if yes, the LS slave will answer one of 16 response messages. This response contains the information of the value of the next neighbor in the value range of 0 to F hexadecimal. So the CAN ID of the response will be calculated according to this equation, so that the LS master gets the value to be checked. The protocol will run till that the master has known the values of all neighbors. That means the master has known the values of all the LS address. Then the LS master switches the identified LS slave to configuration state. So for detail, let us see this example. So in this example, the LS master sends a request to check the value of the neighbor number 3, this neighbor. And here will be the LS address of the LS master requested. So it's also the value in the portion. And here it is the LS address of the LS slave. The LS slave will be identified. So we can see the neighbor number 3 of the LS master request is still unknown, and the value from the neighbor 0 to neighbor 2 are known, and the LS slave received this request and compare to the LS address itself and see, the numbers are the same from neighbor 0 to neighbor 2, and then the LS slave will send a response with value of the neighbor number 3 back to the LS master. So to understand the protocol better, we can now see the messages for this example. So for the request, this data field is set to 3, and the portion parameter is set to 006. So then the slave received the request, and compare the value of the portion of the master and itself, and then they are the same. So then the slave sends the response with the CAN ID with the value of the neighbor number 3. So this will be 7DD. So then the master processes the response and then packs the value of the neighbor into the next request. So you see here the portion for the next request is 006D. Then the master sends the second request with the neighbor number 4. Then the LS slave handles the request as above described. till the master has known the whole LS address of the slave. So one other important parameter you can see here is TIM. It stands for LS master timeout. Within this time, the LS slave shall generate one LS response. The maximum launch timeout is specified in the range of 1 millisecond to 100 milliseconds. First test implementations has shown that if LS slave and LS master are capable for real-time behavior below 10 milliseconds, that means the LS slave replies to the LS master requests in less than 10 milliseconds. The detection of an unconfigured device and the assignment of a node ID can be completed with less than 350 milliseconds. So this is a significant improvement in comparison to the previous fast scan mechanism that took about 1.4 seconds to complete using 10 millisecond timeout. So now on this slide, we can see an overview how we use switch state selective FD to identify one CANopen FD device. So if LS address is known, we set portion address to the complete known LS address, or neighbor, and set the neighbor number to 32. So if LS address is not entirely known, so we set the portion address to the partly known LS address and set the neighbor number to the first unknown neighbor number. So if the LS address is unknown, the data field portion address will be not used, and they will set to 0, and the neighbor number is also set to 0. So benefited from CANopen FD, this new service as switch state selective FD merged the function of switch state selective and fast scan in CANopen. For the use case, if the LS address is complete unknown, we need a maximum 33 paths, requests, and responses. So with the updated protocols for CANopen FD, the general sequence for assignment of network ID and node ID is shown here. For identifying and selecting one slave, we use switch state selective FD. And for configuration of the network ID and node ID, we use the updated protocol configure node ID and configure network ID and node ID protocol. So to sum up, this new service LS switch state selective FD makes the operation sequence of identifying and selecting an LS slave simpler, more flexible, and more effective. So we need now in total at a worst case maximum 33 pairs of requests and responses. So also This service will be specified in the CR 1305 document CANopen FD layer setting services, and which is now currently in the development, but expected will be released soon. Please note that also the CR 1305 document is not backward compatible to the CR 305 document because CAN-FD is not backward compatible to CAN. So at the last, the LS switch state selective FD mechanism can also be used on other CAN-FD based systems using other higher layer protocols. So this is all from my presentation. Thank you for attention and listening.
So the topic is device description and testing, and it is related actually to our new technology, CANopen FD. So in this one, I would give you a short overview about testing in itself, what we have done by now, how it is done by CANopen, and again, the goal and the reason for that we maintain backwards compatibility, or at least would like to keep as far as it goes the backwards compatibility. So to CANopen. So then we go into details how the CANopen device are described, what do you need there, and how can I test the devices in general, how can I verify if the devices containing CANopen FD. So, and where we get the overview of the results. As I said before in a previous topic, we are still work in progress with the documents to this. The same applies also to this one, but we'll go to that forward. The first one is to tell you what we are talking about, device description testing. For those who have not experienced yet in this one, we're offering for about 20 years already conformance testing of CANopen devices to verify how much of CANopen is inside. This is a very important topic to reach the interoperability, compatibility, and even to a certain degree, the exchangeability or possibility of exchangeable devices on in a network. So why it is done to simplify system design and allow to purchase devices of various other manufacturers and get them replace the device, and the devices should, without any advanced and additional fitting, be incorporated, integrated into the network. So the conformance plays important role. This means I can purchase a device, I'm sure then that it contains exactly the things I expect them to have to a certain degree. So embedded network could have plenty of devices, not only one, but plenty of this. And I want to make it, the device should be interoperable. And the first stage in this would be to achieve at least that these devices are from their data interface or CANopen interface, they are compatible to each other. This calls conformance of this device to the CANopen in this case. Conformance can be achieved in every stage of the device as a model, communication model. So on this physical data and application layer. We do not consider actually the any layers except the application, because we test purely software, and test the protocol in itself, assuming that the CAN controller or CAN FD controller in this case, or physical cabling, the transceiver and cabling are already conform and already qualified, so we test actually on application. But in general, in performance testing, you could achieve certain degrees of compatibility having this done on all layers. The CAN and CAN FD devices fit into this one, and there are certain standards which prescribe what are the requirements for the conformance and which of those should be fulfilled to say the device is conform. There are standards which go a step forward and said, okay, we have these standards about the requirements in general, and then we can define the test cases. For now, there is a test case defined not only for application layer, as is for CANopen or CANopen FD, but also for a physical and data link layer. For now, it is not interesting. We see why it is interesting in the next slide. For now, I would like to say just that in work in progress, what we do with CANopen, many things are done. There is CANopen testing, CANopen device description, CANopen testing. And for CANopen FD, we're working on these two things. We have a testing procedure for CANopen devices, only for devices, not for the network. This is a completely different topic. This will be interoperability testing. And we work on test plan as of right now. In the meanwhile, before no test plan is available and is still in progress, the testing procedure come up, and we actually right now can test CANopen FD devices. Based on a test plan for CANopen FD, similar to the CANopen, the CANopen FD test tool will also be developed, but we are not yet in this. We are going this direction, but we are not yet there. What is the device description? The device description is that the device is not just a bunch of protocols which are specified by certain standards or specifications and are embedded, implemented in a protocol stack. There is also the interchangeable data which serves the purpose to configuration and application data which can be exchanged between the application itself and the protocol stack stage. So we have this intermediate database called object dictionary. It contains the parameter for configuration of the device, a configuration of the CANopen protocols. Also application data is there. So this data object dictionary is where this information is stored, and without accessing it, without knowing what is inside, I cannot do the testing of the protocols or the device in itself. I have to find out how I can access this. This is why the device description comes up. It describes the functions of CANopen FD device in this case, and CANopen or CANopen FD device in this case, and there are parameters in there which I can check against and keep up with the requirements I have in a basic CANopen FD specification and say, okay, the parameters, communication parameters in the first place, they exactly fit into this requirement, they comply with this requirement. So based on it, I can say the device description is compliant, at least on this stage. Furthermore, the device description, beside of this description of each single parameter, serves for the test tool, or could serve for the test tool, where I test the protocols and other features of CANopen FD with using its parameters. So it has a multi-functionality in this case, the device description we have now. So for the information, we have by now certain distinguishment. We have already these things already in CANopen. I want to do similar things, but considering the advanced capabilities and functionality of CANopen FD in the CANopen FD. So in CANopen, we had two ways of describing the device parameters and functionality. Was text-based, actually Windows INI format-based file as key and value, and also XML-based format for this device description was proposed. Text-based, INI-based was called EDS, electronic data sheet, and XML is called XDD, device description. Mostly of those, the text-based format was used, was pretty simple, is human readable, and so on. And it has certain simple advantages because it's pretty simple, can be integrated also in the automatic configuration tools and so on. So XML is more advanced. I could do pretty many things. I could do variable things which are not possible in textual format, but it requires many more resources and was pretty advanced, had included plenty of features available, but was too much for to a big format for using it for simple CANopen devices. So we kept up with this circumstances and tried to simplify the XML-based description for CANopen FD. And the point was actually that there is sorry, can you hear me still?
Yes, we can.
Okay, I just got the call. I thought it did something went wrong. Okay, anyways, well, we continue. So we're talking about CANopen FD. And in this case, we don't have any textual-based format. We have only XML-based because the standard technique is a standard state of microcontrollers and host controllers is that they could actually easily use XML-based description. And it was the requirement from our oversee committee for technical groups that we should use unified XML-based description for all CANopen FD devices. So we have two kinds of device description. Is device description itself, and it can be a description of the configuration of my device, which is used for system design in this case. So for now, we're not considering this topic in this, but this is just good to know. So the final topic, final slide in this case is actually the specification you may consider to read or evaluate for this, and which are used for this reason. For testing, conformance testing on each layer of ISO communication model, so physical data link layer, and finally application layer for CANopen and CANopen FD. So mostly the physical and data link layer and a conformance test plan, which you can see in the very first three standards you see, done by automotive and for automotive reason to qualify their the hardware itself, the CAN-FD controller and CAN-FD transceiver. Why are they important for CANopen FD or CANopen conformance testing? Well, basically they are not. They would just be very suitable for another topic which is not of today. For interoperability, you can test your system design by testing by using some requirements, having the standards for physical and data link layer, and even reuse some conformance test plan for physical data link layer for your system design, as my colleague described you in a previous topic. The standards can be used for interoperability testing, and we actually have a working group on it currently with not much progress, but we're working on it. So to bring system design as well. So, but turn back to our conformance testing. The important specification on CANopen side, there are 300 series documents. We had conformance test plan, we have text-based device description 306, and we have 311 for XML-based. These are enormously complete, having everything inside XML-based device description. So on the other hand, we're working on CANopen FD, same things. Again, the goal having backwards compatibility and functionality of this one. So we said we have already, based application layer CANopen FD, containing most of this functionality for slave devices, and we could test it, and we tested actually. Our conformance testing is against this specification. So on the next stage, we need a test plan, which are working also, 1310, is work in progress. But we have to consider requirements coming from CANopen FD. And another thing we said, important, the device description is not only for description of device, but it's used also in testing, conformance testing, for checking the parameter and protocols of CANopen FD. It is currently work in progress as well, but we are shortly before releasing it. We're having most of the things there. We're talking about these specifications in details in next slides. So each single topic, device description, then conformance testing come up next. Device description, CANopen FD, as we said, XML-based format. So we learned from our, say, mistakes or maybe irregularities, which brought our good and actually very fine XML format description containing every possible functionality for embedded CANopen devices. So, however, it was very big, and our members, which control this process of what we specify and what we can test, which is the reason for this one thing, said, yes, we would like to have an XML format for device description, but it should be that kind of simple and reusable like the text format for device description in CANopen, but having, of course, advantages of XML and using all the new functionality provided with CANopen FD. Said, okay, we do so. So the same, we specify also this stuff for device configuration, but this is for another topic. So go back to the XML-based device description. We verify the parameters and the description in itself should be, on one hand, relatively simple, should not contain, should contain at least the same basic functionalities was before then, and it should having not less advantages than it was with CANopen for text-based format. So considering this, we set also backwards compatibility, the universal standard ISO 15745, covering general description for CAN-based communication profiles such as EtherCAT, Ethernet Power Link, which are basically CANopen, but with other data link layers, and also Modbus. So we said we reuse the same standard, which is a partly description of this XML format, and we do this for CANopen FD as well, same way it was done for CANopen. However, there are some differences. Regarding the ISO standard I mentioned before, we haven't changed anything. So this means we can reuse it, and CANopen FD can be just integrated the same way as CANopen FD alongside other communication profiles into the device. But description itself related, we see XML scheme. What is the difference then? So as I said, backwards compatibility is mostly 3.11 based one, but we simplify this very. We specified only mandatory functionality. So the optional can be done, but this is not a part of this one. And optional ones, there are the functionality which makes this format pretty big and difficult to handle. So you need to program very much on this one. So the format is suitable for very simple device. However, we do not support functionality, modularity of devices for now, description of that. And we put the new functionality allowing to do the system design as well. For conformance testing, it doesn't bring anything, but just for device description, we're talking about device description, which can be reused also for system configuration, network ID, and the reference designator. This is for system design. Network ID, however, is a mandatory capability and it shall be tested. So it is integrated into XML format. The bitrates my colleague mentioned before also integrated, the CANopen FD bitrates also integrated in this part as the reference to the specification were defined with a bit timing. So we can reuse them. And we have also advances. We use the functionality of CANopen FD which come with this. And what I've done before, this NMT master functionality support is also provided in this new XML format for CANopen FD. This nice snippet, I cannot for obvious reasons show you everything there. Oh, plenty of documents, plenty of files in there, XML-based files in there. I just give you an opportunity to see how would it look, at least a piece of it that you could use, and it is actually pretty simple. And here you can see this is standardized profile description, and the device-related parts as parameters, bitrates, and other functionalities support everything will be done and is designed in separate XML files. So, okay, so it's not yet finished. For this one, I just want to mention we have a separate into parts. One describes actually a template for XML-based device description, which is called XDD. And the schemes both schemes are supported. And a schemes contains also to a certain degree, not only mandatory, but also some optional features you could extend within the support of what is designed in CANopen FD basic specification 1301. So we don't go over every optional functionality possible, where we limit ourselves to the very mandatory and the optional features within it. So to make this pretty simple, to make the design of CANopen FD devices and device descriptions pretty simple. So the specification I need for this reason is obviously the basic specification, which I know the content of information. There's also for the certain devices, you need device profiles, which are also adopted currently also for CANopen FD. And we have this specification, which we are working on yet, and she will be soon released, hopefully. We actually define many things we wanted to in there. And for Canyon Automation members, this is a possibility, of course, to check up on this document without any problems. But non-CR members have, for now, no access for this. They have to purchase this, and we're working on it to bring this specification also for being able to be purchased and so on. So, device description so far in general, what we have done, what is yet to be done probably, and then we come to the part of conformance testing. Here in this case, we have already done marvelous job on CANopen testing. We have test plan, we have test tool, we have some technical support on how to handle the testing, what tests are actually can be done, which test can be done under certain circumstances, which cannot be done, and so on whatsoever. And this you have a picture of this general test bench. What we do there, we do not test completely device profile, device functionality, because we don't have an equipment. Imagine that I need to test hydraulic pump or hydraulic drive. I need the whole system for this one with fluids, with the pumps, with various components of this one. This is not possible to do at Canyon Automation Laboratory. Every device designer may have this capability, so we just limit ours to the pure software testing of the devices, one-to-one test tool and a device, and we test in a lower test the application services, object dictionary, and communication service of the device. The same we will do in CANopen FD, and as of right now, we don't have test plan, we don't have test tool. We're working on a test plan, but we have actually an approved testing procedure, which is capable of testing. With this one, we're capable to test new implementation of CANopen device and can say if this passed, if this procedure is performed, fulfilled successfully, the device can be certified for now. But we're working on a test plan, and sooner or later we will have a test tool for that, which you could use for for testing your device in an early stage of the implementation, for testing of eventual problems within CANopen FD. So the test procedure set is specified. It is clearly covers mandatory functionality, relatively simple testing. If no errors detected, we certify the device. you could check this out yourself, and this could be done right now. So, the test plan. The test plan, we wanted to keep up backwards compatible. We have some functionality of CANopen which is not actually available now. In CANopen, these are USDO protocols, some changes in parameters, as my colleague Mr. Zitzmann already mentioned. There are, besides USDO, there are also emergency protocol is changed slightly. So this change says that there is no backwards compatibility, nothing of this exists in CANopen. So we have to redefine some procedures, but it is also the thing, we have XML-based device description, which we have to test within a test plan, test it itself, the device description, and the parameters which we test will also be XML-based. So far, so good, no problem to writing the parser for this, but the point is, of course, that we wanted to make the structure of the test case, of the test plan, more standardized one, and that is why we took the structure of the test cases from the ISO standard for automotive, this 21806-1, and we adopted this for our test plan. So we describe each single test case for every CANopen FD protocols we test, a CANopen feature we test, and you have this kind of comprehensive test case catalog where the test case are atomic test case, say they're very simple and address very single functionality at once, and you could know from this test case what is done there, what is requested there, and you could follow this test procedure and can understand what is going there and can comprehend what is to be done and what should be the results. Basically, you could keep up with the test tool one day or another and verify what is happening. Does the test case test what I'm expecting, and so on. Clear test description because of this new structure. And we said again, we test only mandatory functionality, and we test against the requirements in 1301. So the modular concept of testing of devices is not supported for now. It's not important. We're testing as again always the single devices. Maybe one day we come up with this mass parallel testing of several devices, but it's not that day yet. So in a snippet, you can see this new structure, how we define this, and a very simple step. You could follow each step and you do understand exactly from each step what is going on there. So it is done on behalf of our members, asked for that. They wanted very exact steps to be clearly recognizable. The specification for this reason, for that one, 1301, and also, of course, XML device description I need for that to know how to test that. The profile itself I need to know. However, the device description of the profile is needed there. That is why the specification. And finally, the conformance test plan 1310-1, which specifies my test cases, basically my test case catalog. On the other hand, we wanted to do as next step when we design this, also describe exactly the implementation. How do we implement the test plan? How do exactly we implement the test plan to make this easy to transit between this test plan into the test tool implementation. So, and then finally, this ISO document, ISO standard, which we use, from which we use this structure for this test case catalog to do this more advanced, more exactly understandable what is happening in each test case. To summarize this stuff, say we're working on the device description, XML-based description, the only one description format, it's work in progress and soon be available. Test plan, we're currently working on in progress. Test procedures available, starting of testing can be done for CANopen FD. Right now, the test development is on hold until test plan is developed, as far we wait. And again, the same as this previous topic of mine, we check out if the migration path of CANFD and CANXL capable functionality can be also tested. This is just for the case. So far, so good. You see our progress on this one. If you have any questions, there is a good time to answer, ask them either by chat, or you could write down the email to me, to Canon Automation, as far as it goes. So, any questions? If there are no questions for now, I would like actually to, let me check this out. I would like to ask you if there are any questions in general. Then I have a couple more slides that I would introduce to finalize our today's event. You learned plenty things today, just maybe in some very basic overview, but at least you get an impression what we do at Canon Automation, what we offer, what is done by now, and what if you need some assistance, you develop embedded devices, CANopen or CANopen FD. In this case, what, where, and what should you ask? What would you like to ask? And whom should you ask this? We have certain services. My colleague, my boss actually, Reiner Zitzmann, already mentioned there in details. We have certain email services we offer for our members. And we have newsletters as of right now. You can follow us on social media, ask questions in there, but I would recommend in the first place to ask questions directly by our service email. Our email services offering overview for you, for members and not members, recent development in CAN embedded area, in CANopen FD related application fields, and what is going with our events from Canon Automation itself, what we are offering, what we're doing recently. So, depending on how this situation with pandemic develops on there, we actually organizing exhibitions or participating in exhibitions. If it goes smoothly and we allowed to go and what happening occurred there, so you can just see the trade shows where you could meet us, contact us, and talk to us and represent your products eventually, and can come up with your questions also into these exhibitions. So, beside this one, we have also activities, webinars, if you're interested in some specific topics in there. Our next webinars are listed on our website, just a short snippet on this till the end of the year. Maybe some additional webinars will be blended into in a short while. It's just a brief overview. Recent actual information you can find on our website on these webinars. If you want to know something else, something additional, CAN Excel, CAN FD, J9039, CANopen IoT, and further topics, you can come to our online webinars taking 1 hour by giving you a short overview of what we are doing and what you can get from us. So, next technology day, like these online days, we have Monday and okay, we haven't entirely, but today we have one. Same one would take place in October, November, and the topics will be CANopen profile related, especially 447 for CANopen car add-ons, this kind of audiovisual information providing special cars like police cars, emergency cars, and so on. The topic will be discussed into details how to handle this profile, how to design your device, what you need to know about this, where do you get this information, how do you handle your profiles, protocols, what protocols do you need, what devices can you design with this profile, how it is handled in general, designing of the profile and designing a system based on such profiles, 447, and also for lift application profiles. All those things you will learn, of course, in a separate thread and separate topic. You will get information on how to do so in approximately October, November. We will get with certain dates very soon, hopefully, when we could offer this tech days. It will take also a couple of hours to get you introduced in these topics. And finally, if you want to you would like to contact us for whatever reason, either it's just technical question, or you want to give your some advertisement, or you would like to participate in our joint activities, or would like to be a member and participate into improving of the specification and bring your own requirements into the certain CANopen specification or CANopen FD specifications, you can do this as being our members. And of course, you can contact us on our social media at recognize what we do also in various areas of application, how we inform our members, and what is going on in CAN-based application-related fields. So far from my side, thank you very much for your participation. Hopefully it was quite comfortable for you to sitting before your screens and just hearing what we say, and that you don't need to have going somewhere, just sitting in your chair, or maybe you're sitting in before your computer and your work. But anyways, it's quite comfortable way for now due to pandemic, and independent of this one, it's just a very fine way to have this information brought to our prospective customers, to allow them to decide however they would like to have the information from us or working with us.
So thank you, Oskar. Are there any general questions remaining? Open to CANopen FD and the subjects that have been addressed. I don't see any further questions in the screen. There had been another one asking for the video recording, so we make it available as soon as we have the recordings from Zoom. This will take a while. The slides will be made available later on to all registered parties. So I don't see any further questions. Last time the possibility. Otherwise, so Oskar is sharing his screen and indicating the contacts depending on your subject, advertisement, exhibitions, events, technical inquiries, and so on. So you find here the corresponding possibilities to contact us or just give us a call in the old-fashioned way. So if there are no further questions, I thank you for attending this Technology Day. I hope it was a beneficial event for you. And also, if there are coming during the work some questions, then you are free to contact CANopen, and we appreciate to answer your requests. So thank you very much from my side. Bye.